So in 3.1, we're going to look at quadratic functions. And just always remember, the word quadratic refers to any equation to the second power. Okay? So we're going to be looking at graphing, identifying some different aspects of quadratic functions that are graphed. And we're going to look at it in two separate forms. One is vertex form. So the word vertex refers to, in the U-shaped graph we've been dealing with already, the point of symmetry in a way. Okay, it's the lowest point or the highest point. This form right here, if you have an equation in this form, you're given the vertex, which kind of gives you a good starting point for how to graph it. Because you can always sketch a graph if you know the vertex. Now, general form, as I call it, is what we're kind of used to seeing more. Ax squared plus bx plus c. And also keep in mind that a, b, and c, it's not the order they're written in. It's a is times x squared, b is multiplied by the x, and c is the constant by itself. So if I look at vertex form, we are still able to determine whether the parabola opens up or opens down by the sign of a. So if a is positive, it opens up. If a is negative, it opens down. Now the vertex, which is a point, x and y, we call it minus hk. Now in the book, they just call it hk. Then they go through changing signs, all this stuff. I don't know why they got to make it that difficult. I'm sure there's a reason for it. But I'm just going to tell you the vertex is opposite of whatever h is, and then k, and then you've got your vertex. We can always find x-intercepts the same way, it never changes. Set the equation equal to 0, solve for x. We can find the y-intercept by letting x be 0. The maximum or minimum value, since it is a quadratic, it's only got the one hump. We only have either a maximum or a minimum. If it opens up, we have a minimum. If it opens down, we have a maximum. And it is the y-coordinate of the vertex. Okay, so let's just look at an example on getting the vertex. All right, so the coordinates of the vertex. Minus hk, opposite of negative 2 is 2, k is 12. Okay, don't overcomplicate it. All right, so that's where the vertex would be for this particular quadratic. Now, a is negative 3, so it would open down. We could certainly find the x-intercepts, y-intercept, but we can sketch the graph knowing that it opens down and we have the vertex. For this equation here, my vertex is minus 1, minus 6. A is 2, positive, so it opens up. So, you know, it's going to look something like this, okay? And this point here would be the one we could plot. And again, we could certainly find intercepts to get more points if we're asked. So that's just finding the coordinates of the vertex. Now, if we have an equation in vertex form, we want to find the coordinates of the vertex, the intercepts, sketch the graph, and we want to identify the axis of symmetry and the domain and range. Okay, so let's first of all look at the vertex. And it is the opposite of h and k. So my vertex is positive 1, negative 2. X-intercepts. So I'm going to set the equation equal to 0. Solve for x. Now here's where you have options, okay? If you can think back to quadratic equations, we solve these by the square root method. I could add 2 to both sides, take the square root of both sides, go from there. I could also expand this by using my FOIL method, subtract 2, and use the quadratic formula, or factor if possible. Okay, so One way to do this is to add 2 to both sides. Then take the square root. Remember, it's plus minus. And I get x minus 1 is plus minus square root of 2. Add my 1 to both sides. So x is 1 plus or minus the square root of 2. Now, we're going to have to plot these. So you have to have an idea of, whereabouts this lies. So if I take the square root of 2, I get roughly 1.4. So x is 1 plus 1.4, or x is 1 minus 1.4. I just need an idea where to plot this at. So x is 2.4, or x is negative 0.4. So therefore my x-intercepts, and of course I am running out of room like always, are going to be 2.40 and negative 0.40. Make sure I got those right. Okay. All right, now my y-intercept, I let x be 0. So I get 0 minus 1 squared minus 2. Okay, so I'm just putting 0 in for that x right there. Okay, be careful as you work through this. So that gives me negative 1 squared minus 2. Negative 1 squared is 1, and so I get 0, negative 1. Okay. So, to sketch the graph, I first have my vertex, 1, negative 2. I've got my y-intercept, if you can recall, of 0, negative 1. And my x-intercepts, 2.40, so I'm just estimating negative 0.40. And that allows me to sketch my graph. Okay, so that's how, you can use sketch the graph that's in vertex form. Axis of symmetry. Well, this right here is the axis of symmetry. It's the x-coordinate of the vertex. So your axis of symmetry is the line that cuts the graph in half. It is a vertical line, and as you can see, it went through 1 on the x-axis. So it is your x equals 1. Domain, anytime, and we just talked about this, in the last chapter, as long as you do not have, at this point, a fraction, square root, your domain is negative infinity to positive infinity. So my domain, negative infinity to positive infinity. My range, I'm going to get that from the graph. So it looks like my lowest y is negative 2. That's kind of your minimum as well, is negative 2. And it gets bigger. So my range is negative 2 to positive infinity. Okay, so that's things you're going to have to identify. A was 1 here. Even though we don't write it, we assume it's a positive 1, and that's why it opens up. Okay, so that's kind of going through the graphing, finding stuff that you need to know from a quadratic and vertex form. Now, we're going to look at one that's in what I call general form. So there's advantages and disadvantages to either one. Putting an equation in vertex form can be time-consuming. But if it's given to you in vertex form, it's pretty quick to find the vertex. A little more difficult to find x-intercepts, okay? So there's good and bad to both formats. So again, A, positive, it opens up. A is negative, opens down. The vertex, we have a formula to find the coordinates of the vertex. X-intercept and Y-intercept does not change. Max or min does not change. So if I look at x squared plus 2x minus 3, it does open up my vertex. Just make sure, and this I see people mess this up all the time. Once you find x, you need to put that back into the equation to get y. So my x coordinate is minus b over 2a, which is minus 2 over 2 times 1, because a is 1, b is 2, c is negative 3. And so that gives me negative 1. Then I find my y coordinate, and that is f of negative 1. Put negative 1 back into the equation. So f of negative 1 is negative 1 squared plus 2 times negative 1 minus 3. So that's 1 minus 2 minus 3, which is negative 4. So my vertex is negative 1, negative 4. X-intercepts. I'm going to solve. X squared plus 2x minus 3 is 0. So I'm going to factor. X plus 3 times x minus 1 is 0. So x is negative 3 or x is 1. So therefore my x-intercepts are negative 3, 0, 1, 0. Make sure you don't make this 1 point. These are two x's, so they have to both have a y of 0. Then my y-intercept, f of 0, is 0 squared plus 2 times 0 minus 3, which is negative 3. Okay, so I have nice whole numbers for every point I need. I can go ahead and plot 1, negative 4, 0, negative 3, negative 3, 0. Oh, excuse me, that's 0, negative 2. Sorry about that. I got everything screwed up here. 1, negative 4 is here. 0, negative 3 is here. All right. Been a long day. Negative 1, negative 4 is the vertex. I'm not even paying attention to what I'm doing. I'm just going to regraph that. I apologize. Okay. You can erase. I did it in pen. Negative 1, how about negative 4 is here. 0, negative 3 is here. Negative 3, 0, and 1, 0. Sorry about that. It happens. Okay. So that's the graph of the quadratic equation. Now your axis of symmetry is the x coordinate of the vertex. So my axis of symmetry is x is negative 1, right there. My domain, as always, with quadratic, negative infinity to positive infinity. And then my range is negative 4 to positive infinity. Okay? So sorry about the mess up on the graph. All right. So that's graphing a nice one. Now let's look at one that might be, a little bit more difficult, just because we're not going to be able to factor this, okay? And it's got a negative on the A, which means it's going to open down, okay? So I'm still going to find the vertex. And in this case, A is -2, B is 4, C is -5. So my X coordinate is minus B over 2A, which is minus 4 over 2 times -2, which comes out to be +1. Y coordinate, find f of 1. So f of 1 is -2 times 1 squared plus 4 times 1 minus 5. Careful here. That's going to be -2 plus 4 minus 5, which looks like it's going to be -3. So your vertex is 1, -3. See if we can get it right this time when we plot it. All right, now you may be noticing something because, see, if I plot my vertex 1, -3, and my y-intercept is down here at -5, I'm not going to have any x-intercepts, okay, because it opens down, all right? But this is y, okay? So I can't factor that, so I'm going to use my quadratic formula. So minus b plus or minus b squared minus 4ac all over 2a. So minus b plus or minus b squared minus 4 times a times c all over 2a. Now what happens here is, underneath my square root, I get 16 minus 40, which is -24. That's no real solution, so we have no x-intercepts. So we have none. The y-intercept is at -5, so really to sketch the graph, that's all I need. In this case, we do have a maximum value. So my max value is y is -3. My range would be -infinity to -3, okay? If you are asked to find something like that, -infinity to -3 would be my range. Okay, so that's the deal with a quadratic that looks like that. Okay, I will probably, hopefully remember to do this one in class. I see I'm kind of getting a little bit long. I mean, not too bad, right at 20 minutes, but I don't want to go too long. But we'll work something similar to this one in class. Let's look at max-min values. You know, you can find a maximum or minimum value without graphing it, because it is the y value of the vertex. If the parabola opens up, then it's a minimum value. If the parabola opens down, we have a maximum value. So for this one here, A is 1, B is 4, C is 0. It opens up. I'm going to find the vertex. So x is minus b over 2a minus 4 over 2 times 1 is -2. F of -2 is -4. So my vertex is -2, -4. So again, it opens up. So my minimum value is y equals -4. The y coordinate of the vertex, it's minimum because it opens up. All right. Let's look at the other example. So in this case, A is negative 3, B is negative 12, C is 4. Opens down, so we have a max value. So I'm going to find my vertex, minus B over 2A, minus negative 12, becomes positive 12, and my x-coordinate is negative 2. F of negative 2 is negative 3 times negative 2 squared. A lot of negatives here, so be careful. So that's negative 12, 36, looks like 40. Let me double check that. 4, so negative 12, no it's not 40, plus 24, plus 4 is 16. How about that one? So my max value is y equals 16. Okay. So there you go. You know, like I said, we've got two forms to look at for the vertex, and either one of those has its advantages and disadvantages. So we will talk more about this the next time we meet.